In this video, we're going to sketch this parametric curve. We are going to sketch this parametric curve. So starting out by drawing this graph. So this would be your x location, and then draw your y location. So your x location, sketch this graph. So when t is small, it wants to do a negative gradient of 4, a negative gradient of 4. When it's big, it wants to do a cubic. So it would do something like this. So your graph will end up looking something like this. And then sketch this one, that will then give you this. Now looking at this, this tells you the x location for given time. So imagine that your timeline here, so we're going to start from 0 and then move towards infinity. So looking at this, this tells you the x location. So if you look at this, as time moves on, so if you start here from 0 and head towards infinity, you're really starting from here, from 0, and then heading towards infinity. But this thing here tells you the x location. We will talk about the negative side later on. But let's just concentrate from time equals 0 to time equals infinity. So 0 to time equals infinity. So if you look at this, this tells you the x location. So when t equals 0, the x location would be 0. So it must start here, and then because it goes down, this tells you how far to the left it must be, because x will be negative. X will be negative. So looking at this graph, what it's telling you, this negative bit here will indicate this. It's going to go to the left, and then it's going to go back to the right, and then all the way to the right. Because looking at this here, you start here, because when t equals 0, the x location would be 0. Now it's going down, so that means from here to here, it will move to the left because x is negative. So it's going to move to the left, and then it's going to reach its maximum right here, maximum to the left, and then the x location will head back towards 0. So the x location will then head back towards 0. So this bit here will correspond to this bit here. This bit here will correspond to this bit here. And then it's just going to move to the right all the time. Then it's just going to move to the right all the time. And then if you look at the height, this tells you the height of the particle as time moves from 0 to infinity. Well, the height is just going to get higher and higher and higher. So what it's doing is you've got to combine this. You've got to combine the movement in the x direction, move to the left, and then to the right, and then keep on going to the right. But then the height is always increasing. So as it turns out, your graph will look something like this. But let's try and extract more information. When t equals 0, we know the particle is going to be here. When t equals 1, well, actually, let's try and locate these points, because these points tells you more about the movement of the particle. We know it's going to do something roughly like this, but let's try and look at these points here. It will give you more information. So let's try and identify these points. So looking at this, factorize this. So t, looking at this, t's in common. So factor out the t. That will then give you this. Easily square rootable, and there happens to be a minus in between, then you know you can factorize it like this. So that will then take you to here, and then from here you can tell that when t equals 0, this whole thing would be 0. So this bit here must be 0, this bit here must be 2, and then this bit here must be negative 2. So that will give you these three locations. So what that means is when time equals 2, let's say when time equals 2, the x location will be 0. So that means hang on, let's start again. When t equals 0 is here. Now if you look at this, when time equals 2, the x location will be 0. So what that means is, hang on, let's start here. So we are now here. So we are moving to the left, to the left, to the left. We are moving to the left, to the left, to the left, and then we're going to move back towards x being 0. So we're going to move back towards x being 0. So really, we are talking about this location here. because what it's saying is this, what it's saying is that we are moving to the left, to the left, to the left, and this will be our maximum to the left. So we're moving to the left, to the left, to the left, to the left. This will be our maximum to the left, which corresponds to this bit here. And then we're going to move back towards x being 0. And then we're going to move back towards x being 0. So when time equals 2, it corresponds to this bit here. And if you want to know this location, then you've got to put time equals 2 into here. So 2 squared will be 4. So this will be 4. And then if you put a 2 into here, it will be 0 because it's this bit here. So this bit here will be 0. Okay, and then as time moves towards infinity, then well, this thing's just going to get bigger and bigger and bigger. So it's just going to get bigger and bigger, and this thing here is telling you it's going to go. The graph is going to go up and up and up. So and if you want to find out the furthest point to the left, which is this bit here, then you can always try and locate this thing here. So all you have to do is differentiate this. That will then give you this, and then set dx by dt equals 0, because you're trying to locate this bit here, the furthest to the left. So find out when the gradient will be 0. So when you set this to 0, t equals this thing here. So when t equals this time, then it will give you the maximum to the left. So that would be somewhere around here. But let's not use this. It's easier just to use t equals 1. When time equals 1, you can put it into here. The x location will be -3. When time equals 1, put this into here. The y location will be 1. So yeah, the y location will be 1. So when time equals 1, the coordinates right here. So this is when t equals 1. It will be -3 and 1. So your graph will end up looking something like this. Okay, and this is an even function. So this thing here is an even function. So it's going to act symmetrical. And then this thing here is going to be an odd function. So if you think about it, your graph will, if you head towards negative infinity from 0, it will look something like this. It will look something like this. But then when you come to draw the arrows on the diagram, you have to start at negative infinity and move towards infinity. So earlier we did it from 0 to infinity, and it gave us this. So starting from negative infinity would be you being here, and then your path, the path of the particle will be like this. So when you come to draw your arrows, do it like this. Okay. Yeah. So overall, your graph will look something like, your curve will look something like this. Okay.